No? What the vertical line test pretty much said was that if you could draw a straight line through the function, which is the picture, the graph, and it did not cross twice, then you were a function. So like in this case, you got a parabola. No matter where I put this line, will it ever hit the function twice? No, it wouldn't. So that means that that is a function, right, Marissa? Can you put that away, please? Thank you. Over here, if you look at the circle, that is not a function. If you put a line through, you're going to cross the function up here and down below, which means that that x value is cheating. Got a girl up here on the north side and one on the south side, so no good, no good. It's not going to function. Let me clear the ink. What? Especially if they're crazy. Okay. Serious?
Dang, it's tripping.
We did this, didn't we?
Yep.
Oh, no we didn't. We did this one and then we stopped. Okay, looking at this one, looking at the top equation, what is the domain of that equation? You guys remember domain, right? It's what the x values are, what the y values are.
No?
No. So what you're going to want to do, and the best advice I can give you is have a calculator, plug that in, and look at the picture. Okay? If you look at the picture of that, it's going to look something like, we're here 7, and it's going to kind of tilt down like this. Okay? It's not a perfect sketch, but I know what it looks like. I have an idea what it looks like. And then I can say to myself, all right, let's take a look at the domain. Okay? If I'm going to cross this x-axis, I've got a value for x there, I got a y value there, I got one there, so forth, right? When will I ever stop doing that in this direction? Being able to jump back up to the line? Never, right? So that means that x actually can go on to negative infinity. And if I go to y, now if I do that in this direction, I can jump down, can I? When will I ever stop doing that? Never. So the domain for this function is negative infinity to positive infinity, aka all real numbers. Questions there? Does that make sense to everybody? Okay, now I'm going to do that for y. Okay, so if I go here, I can jump over that way, I can jump that way, right? I can get back on the graph. When will I ever stop doing that in the negative direction? Never. So for my range, I've got negative infinity, and you can already see that's going to go up to 5. Huh? Infinity. So for linear functions, their domain and range are always going to be negative infinity to positive infinity. Because there will always be a value on x and y. Does that make sense? Cool beans. Let's talk about this other one now. Okay. Okay, that function is going to look something like this. Okay, it's not a perfect sketch again, but it gives me a good idea of what the domain and range is going to be. Okay? Can you ever see my function over there? Yeah? It's the little swirly thing. So if I'm talking about domain, do I have any values of the domain over here on the negative side, Josh? Does this function have any values in the negative side for domain? No. Okay. Is 1 in my domain? 2, 3, 4, 5.5, 6? Yeah. So my domain should not be a parenthesis. Should be bracket, and I'm going to go to 6. And then where am I going to go to? Positive infinity, because it's always going to keep going that way forever, isn't it? Oops, positive infinity. That's horrible. Look like a little snail. Oh, okay. Not bad. You get the point.
Do we have to put positive or
no? No, I put a negative and I didn't want to erase it. I was lazy. I ain't gonna lie, I get lazy too. Domain make sense here? I'm looking at this side. Odalis? You're locked? You need to say something then. Okay, so I'm looking, domain is X, right? This red piece is the function. It's the graph. Is any of the graph, now I'm only looking at x, okay? Only looking at this line. Is the function over here somewhere? Is there any piece of it over here? No. Where does it start at? On the x only. Where does it start at? Is it 1, 2, 3, 4, 5, 6? It starts at 6, doesn't it? So I only have x values from here that way, don't I? That's what that's saying. That's it. Math. Okay? You got to ask, because you don't ask the easy stuff. When it gets to the hard stuff, you're just drowning. Okay? Right now you're like, help, help, I'm drowning. Okay, let's talk about, I put that in the wrong spot. Let's talk about range. Range. I'm looking at this one now. This is the up and down business. Okay? Do I have any values down here in the negative area? No. What's the smallest y I have? 0. Good. So I go from 0, where does it go to? Positive infinity. Beautiful. So there's your domain and your range. Math. I'm going to die over here. I'm going to fall over something. You see me how many times I've kicked this? Go away.
Go away.
Here we go. Cool? Questions on that?
Why is it 0?
Okay, so now we're not looking at this line, right? I'm looking at this one. Is there a piece of the graph over here anywhere? How far up do I got to go to have something of the graph? 0, right? So if I get to 0, oh, there it is.
Oh, okay.
And then from there, I've got more values all over the place. I just keep jumping back and forth. Okay? Continue. Oh, cool. Look at this one. You guys want to try that one? Y to the 4th equals x. You guys remember what I said about y to the 4th? You guys were supposed to be practicing those.
Yeah, why did the 4?
It goes like that.
It looks like a U.
Touchdown.
All evens look like a U.
I thought it was like.
All the odd ones look like a snake.
Never mind.
Okay? U's are positive. Because remember,
We didn't do that one.
sure we
Yeah,
did.
we did.
Yeah.
I said every positive, it just gets flatter and flatter.
So wait, the positive are you, and then the.
Well, think about this. Think about this. Let's say I did put a negative in there.
Okay.
Okay? And if I go to the 4th power, actually no, that's not right. This is on its side. You're right. We didn't do this one. You're correct. That one is actually going to look something like this. So that's not even a function, is it?
What the hell?
You only did the function.
Yeah, that's not even a function.
Wait, so
I apologize. You're right. We didn't do that one. I did y equals x to the 4th, but not y to the 4th equals x.
So is that y to the 4th?
Something like that. It's something like that.
And it's not a function?
No, y is not a function. It fails the vertical line test. See, no, not a function. And if we did talk about the domain, it would be from 0 to positive infinity. See it? It would be from 0 to positive infinity. What about the range? If we could talk about the range. Negative infinity to positive infinity. But this is not a function, so it's gone. Okay. This is also not a function because it's an inequality. And this one is supposed to be not a function either because, oh, this one is a function, 0. The denominator would be 0, and this would be undefined, so it's not included in the domain, but it is a function. Okay. Okay. Take a picture of this. A function is a relationship in which for each value of the first component of the ordered pairs, there's exactly one value in the second component. Okay? A function is a set of distinct ordered pairs in which no first component is repeated. 3, a function is a rule or correspondence that assigns exactly one range value to each domain value. So this is the different ways that you might hear a function described. I think I used my boy-girl analogy. Makes sense, doesn't it? You know, I have to rethink that. I was attacked during 6th hour.
Why?
Oh yeah, that's
Were
Because
you
of the
really?
boy-girl thing.
Who attacked me?
I wasn't attacked. I was just being harassed. It was funny.
By who though?
Students.
What they say to you?
I can't put them on blast.
What they say to you?
I can't put them on blast.
Or what?
What
they
they
say to you?
Why can't it be a boy and a boy or a girl and a girl?
Oh.
That one.
when you said that.
Alberto, why'd you say that?
Stop.
All right, can I continue? No?
Stop.
And you don't have to know them all. Let's just understand that they can be said differently, but they're all saying the same thing, right? Function, x does not repeat the value. Over here it's one, every x is going to have only one y. And here they're assigning one range to each domain. Logic, can you put that away, please? We're good?
Yeah, I have a picture, but I'll just write it on there.
And it's recorded too, so it'll be there for a while. All right. Function notation. Function notation. I want to show you something before I go into the slide. Something looks like this. Y equals 3x plus 2. Everyone understands that, right? Y equals 3x plus 2. So I could tell you, hey, can you solve for y when x is 3? And you would say, yeah, x is... Y is 11, right?
Oh yeah.
Because you plug in the 3, you go y equals 3 times 3 plus 2. Y equals 9 plus 2, therefore y equals 11. So you would say, oh, when x equals 3, y equals 11. Everyone remember that? Okay. Function notation is supposed to help alleviate that whole situation. I'm going to show you function notation right now. And I'm going to take this as an example. Is that cool? This is going to say f of x equals 3x plus 2. You see the difference between the two? The equation over there uses y. This function uses this thing called f of. It is the same thing, okay? Function notation is a little bit more helpful though, because now it, go ahead.
Doesn't that tell you that it's a function without having to do it?
Yeah, pretty much, because it's already a function notation. Okay. They might throw some at you though, still say, is this really a function? And you'd be like, yeah, or you'd be like, no. So they'll give you wrong stuff too. But yeah, right away, if you see the function notation, technically you're saying that's already a function. You don't have to worry about it not being a function. So you're good. Now, over here I asked the question, what is y when x equals 3, right? I don't even have to use words. If I want you to do that, I would say something like, hey, evaluate this. Evaluate this. Now, notice what happened to the x. It became a 3. So what should happen on the right side? What? X should also become 3. And there you go. They're exactly the same thing. Well, they're not exactly the same, but they work the same way.
But they mean the same thing basically.
Except the function notation might give you a little bit more information. Okay? Over here, I could say, oh, the value of the function is 11 when x equals 3. Over here, I actually have to go further and give you something like this, which is, what do we call that? A coordinate, right? An ordered pair. This and this are equivalents. They're telling you that when x is 3, y is 11. Here, when x is 3, y is 11. Questions on that? No? Cool beans. And yeah, the proper way to say it is f of something. And that of something depends on what variable you're using. Moving on. Okay. Go ahead and evaluate those two, please. Evaluate the two, please. Evaluate those. find f of -3 and f of t. Say something, I'm giving up on you. I just saw it on here on Twitter. It says say something. Actually on YouTube, sorry. On the little chat thing. It says say something, ... Ellipsis points. What's up? I'm making sure the status is fine and it doesn't shut off. I have to monitor it too.
In case somebody cuts or something.
This program talks to YouTube, and if it ever breaks, this would tell me here that there's no longer a connection. And if there is no longer connection, why not fix it? Yeah? I'll be the one if you want me to. That one's a little hard.
Wait, so
Do you want me to do that one with you guys? Okay, so f of t, no sorry, that's not a t at all, that's an x. Let me do this. Equals -3t plus 5 over 2. Yeah, I'll just be sarcastic. Don't make it tough. All that's happening is whatever x was, you're switching it for what's inside of the parenthesis now, and that's it. And if you can go further than that, then you do that. But here you can't. I mean, all you could really do is make 2 fractions, but why? It's more room for error, right? I don't want to make mistakes. Oh, I've seen that. They look different from over here. It's the same. It's exactly the same but different. What'd you guys get for f of -3? What's the value of f of -3? I got -2. Is that wrong?
no, I got it. I got it.
Oh, probably positive? Oh, no, it is wrong, huh? It is wrong. I'll tell you why. I didn't see the negative. So this should have gone -3 times -3 plus 5 over 2. 9 plus 5 over 2. That's 14 over 2. So this should be 7. Woo! Man!
Okay, let's
Okay, moving on. Yeah, so here's your, see the substitution? Brittany. Thanks for putting your phone away. Whoa, pay attention. What was your question? All right, cool. Try this one. Oh! Try it. So let g of x equal 5x minus 1, and then they want you to evaluate or simplify g of m plus 2. It's not as hard as you think it is. Even the phone agrees.
Wait, why?
I gotta change that tone. I'm so sick of it already.
Why do you have it? Like, what is it for?
It's my notifications. It was the Power Rangers for a while. I had Mario before that, and then
No, it's Kim Possible.
that's not Kim Possible.
Yes, it is.
It's Power Rangers.
No, it's not. It's Kim Possible. No, it's not. Pull it up.
I have, and Kim Possible goes da 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 not da 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 da.
Oh my god.
It's different.
It sounds the same.
No, it does not.
Okay,
You,
pull it up once we're done.
yeah, when we're done, I'll show you.
How do I go from here?
I don't like that. Funny. Here we go. So I want to evaluate g of m plus 2. That is 5x minus 1, correct? So what do I put into that parenthesis? M plus 2. So g of n plus 2 is 5. That's not an x. I'm so used to writing x. 5n plus 10 minus 1. Therefore, g of m plus 2 is 5m plus 9. When you're done. Questions there? Odalis? Oh yeah, for sure. But there's no questions on this? Alright, cool beans.
Are we done?
I don't know. Once it turns black, I'll know we're done. What's the matter, Callie Burke? Not in math mode today? Man, I didn't want to get up today. I actually, instead of hitting the 5-minute snooze, I went 15 minutes. And then I put it out. And I went 10 more.
I still snoozed for an entire hour.
You snoozed for an hour.
Why do you think I was late? I didn't wake up. I just don't have alarms. I text her
I'm not
like
getting out of bed quick. Well, I have to take my daughter to school, so it's not like I can snooze for an hour. She's in kindergarten. Kids love school. She loves all her teachers. Yeah.
Don't you just have one teacher?
Yeah, I thought it
Actually, in kindergarten, they have 2 teachers. They have a morning teacher, and then they have an afternoon teacher.
Oh, in kindergarten was only
But then she started with Miss Corkston and Miss Geider, and the classes were so full they brought in another teacher, and she ended up with another teacher. So now she has Miss Spitz and Miss Romero. So in her book, she has 4 teachers, and she loves all 4.
Yeah, I didn't have.
No?
I only went from like
Half day?
8 to 11.
Yeah, now it's full day kindergarten. Yeah, back then they only had half days.
I had full day kindergarten.
She
We just
likes
had
it.
a nap. So did I had half day.
You know what's funny? I was reading a post that one of my friends put up, and in the post it said, when I was a kid, nap time was a punishment, and now it's paradise.
No. In kindergarten, I crashed out. Like, I had to have a nap.
Did you?
Yes.
I had kids that hated it. Like, I think they would beat me.
Wait,
I would
which
pass
one?
out before them.
Did they do naps in Head Start?
Yeah.
Yeah. You
Yeah.
used to fall asleep?
I got in trouble a couple times because I was like snoring. I was like,
You would nap with them?
no, I wasn't supposed to, but like there was always that one kid that would fight it, and then be like, oh, rub my head so I can go to sleep, and then rub their head. Oh my God. Especially with the lame music that they put on, you know, like those
They
melodies.
have to.
Yeah, so like, oh, I'm sorry. Yeah, but when they swapped the teachers, the other teacher was falling asleep too, and they didn't tell her anything. So like, yeah, it was something wrong about a guy being a preschool teacher, which kind of bothered me. But like, whatever.
Really?
Dude.
My
Yeah.
mom said that they loved you. Like, you're one of their best teachers.
Aw, thank you.
See, you're just a good teacher.
I was alright. No, well, my supervisor didn't like me when I worked at CAC. It was the development center.
Oh, my mom said
Yeah.
that you were one of the best teachers and that they've never found another teacher like you.
Aw,
Okay.
that's awesome.
No, I swear on everything. My mom like hates all the teachers out
That means a
there.
lot.
And she's the one who hires them. Like, literally.
It's because I got a good reading voice. You should hear me tell stories. I get into character. Like I get in character. Like I could be drama king. Alright, is this a function?
No.
Okay. Yes, it is a function. Now, can you evaluate f of 2? What is f of 2?
4.
It's 4. How do we know it's 4?
Because it says right there.
It says right here, when x is 2, f of x is 4. Have it?
She said if it seems easy, it's not right.
No, it's easy. Math is supposed to be easy. Math don't like hard. We don't like hard at all.
Does like hard.
Alright,
I just took those.
what do we want us to do here? Okay. Oh, is that same function over there? Okay. Continue. You guys are okay with linear functions. You should be able to graph them same way. We're done. Don't say. I'll have the homework ready for you guys in a minute.